Good evening. My name's Jonathan Cooper. I'm the president of the Royal Aeronautical Society. The Royal Aeronautical Society is the world-leading professional organization covering the entire aerospace and aviation communities. One of our strategic aims the past 150 years has been to generate and facilitate the dissemination of impartial and authoritative knowledge and information to both specialists and to a broad audience. One of the ways we're able to do this is via our specialist groups. And it is one of our specialist groups, the Rotorcraft specialist group, that has been the key organisers of this evening. So on behalf of the Royal Aeronautical Society and the Rotorcraft specialist group, I very much like to welcome you to this Hovering Ambition panel event, where we're going to be discussing the future of rotary winged aircraft. The aim of this evening is to enthuse and excite all attendees about the opportunities that the rotorcraft industry has to offer, and to give you some insight as to where the panelists think that the industry is going to be going in the near and not so distant future. Of course, we are delivering this panel session in somewhat strange and unusual circumstances. And on behalf of the Society, I'd like to extend our best wishes to you and your families and hope that you're all keeping safe and well. However, it's gratifying to note that whilst we are not gathered in a physical location, the opportunity that this webinar gives is to reach a much broader audience. And we have over 600 participants signed up from all over the world. So I'd like to welcome everybody here who's taken the time to listen in to this evening's event. We have a brilliant panel of experts tonight spanning the different realms of the rotorcraft industry. But before I introduce them, there are some housekeeping announcements that I need to make. First of all, today's webinar is being video and audio recorded, and these files are going to be shared with attendees about 3 days after the webinar via an email. And these are going to be able to be accessed free of charge. Of course, this is a panel event, so we have the panel, but one of the key things we need are questions from you, the audience. So please, can you direct the questions, and you'll find a question tab in the GoToWebinar platform box on your screen. All of you, the attendees, are going to be automatically muted. So again, if you wish to communicate us, please do so via the questions tab on the GoToWebinar platform box on your screen. So that's the preliminaries over with. What I'm first of all going to do is to get each of the panelists to provide a short introduction to themselves and where they're related to the rotorcraft industry, and then I'll open the floor over to you following one set question that is the only one that the participants will have had the chance to prepare. We're going to run the webinar to 7:30 UK time, and then I'll draw things to a close. So once again, thank you very much for taking the time to tune in. I'm very much looking forward to an entertaining and informative evening, and I hope you are as well. So I'm going to hand on to the panelists now to introduce themselves. And our first panelist is Bianca Irwi, who's a graduate engineer at Leonardo Helicopters. Over to you, Bianca.
Hi there. So hi everyone, I'm Bianca. I'm currently in my second year on the engineering graduate scheme at Leonardo Helicopters. I started off my career doing an integrated master's in aerospace engineering at the University of Bristol. I got to do my own 8-week research project on composite materials funded one summer. And in my final year, I worked on a large group project designing the powertrain for a fully electric helicopter. So that was battery chemistry, battery management systems, and motor design. And I also had to do the gearbox. And yeah, that group project is really where I fell in love with rotorcraft, and I chose to pursue a career designing them. I was lucky enough then to be offered a position on the graduate scheme, and I graduated with the first in July last year. During my first year on the graduate scheme, my placement work has mainly been in the aerodynamics and tactical processing departments at the company. The tactical processing department designed all of the mission system airborne software for the aircraft. And I've been working on a research project looking at pathfinding algorithms, which take a ton of environmental data, so terrain, fuel, time, that kind of thing, and couple it with the maneuver capabilities of the aircraft and use that to develop an ideal flight path for the helicopter. In aerodynamics, I worked on the integration of two codes written in different languages, Fortran and C, and which together would be able to simulate the coupled effects of the dynamics and aerodynamics on the helicopter. And on top of that, I also did a CFD research project and helped prepare some design work for an acoustics analysis on one of our current designs. And then also as we went into lockdown, a group of 8 engineers, including myself, chose to enter into a RAeS design competition, which takes place every year. But this year it was to design a vertical takeoff electric aircraft for a humanitarian aid mission. And I got to analyze the aerodynamic and stability characteristics of the aircraft. And I had to work together with other group members to create a viable conceptual design. We had to put our final design into an aircraft simulator to demonstrate its performance capabilities. And more than anything else, the project really brought home how difficult it is upscaling a project from conception to final implementation at a level where the aircraft can actually be certified. And so really that sums up my experiences so far. And it's really just shown what an engaging and challenging field the rotorcraft engineering can be. Thank you, Jonathan.
Brilliant. Thank you very much, Bianca. Sounds like you're making an excellent start to your career in these strange times. Okay, our second panelist is Brett Peterson. He's an aircraft architect, IPT lead for vertical aerospace. Over to you, Brett.
Thank you, Jonathan. I seem to have unmuted myself, so that's the first victory for the evening. So, a brief introduction to my background. I am an Australian, as you may have guessed by the accent, and I started my engineering career studying mechanical and space engineering and physics at the University of Queensland in Brisbane, Australia. And those degrees seem to complement each other well. The engineering side kind of scratched the itch of the application of science and technology to solve problems and make things. Well, the physics side let me kind of peel back some of the layers of abstraction that are used in engineering and to keep kind of digging as far as I chose in those areas. And this kind of practice of peeling back and going between different layers of abstraction has kind of been a common theme throughout my career and kind of where I've ended up now at vertical aerospace. So after graduating, I started my career at GKN Aerospace in Australia, and that was in the engineering automation team, where we were creating software for structural analysis and design for partners on the F-35 program. Moved through stress engineering, on-site integrator and project management roles, and that was really, really interesting, gaining a experience on a large number of different aerospace platforms, UAVs, general aviation aircraft, commercial fixed wing, military aircraft, and rotorcraft. Following that, it was on to the A320 Sharklet program here in the UK and Korea. And that kind of broad experience across many different cultures and continents really kind of helped me to understand the regional differences that are actually quite strong in engineering, particularly in aerospace. Following this up with some research and development when I joined the fledgling National Composite Centre here in Bristol, acting as a technical lead for multidisciplinary teams and the concept design team. And this was across the life cycle of composite manufactured components for aerospace, automotive, energy, and rail. Co-founded an engineering services business and acted as the head of engineering. And that brings me to my current role, where I am the architecture IPT lead at vertical aerospace and have been there for the last 18 months. And that's really been quite an interesting journey, and hopefully some of you have seen our progress over the last few years, developing 2 full-scale aircraft and onto our 3rd at the moment.
Brilliant. Welcome on board, Brett. Our next panelist is a colleague of mine from University of Bristol, so Jamal Rezgui, who's a senior lecturer in aerospace at Bristol. Over to you, Jamal.
Thank you, Jonathan. It's a privilege to be part of this panel. As Jonathan mentioned, I am a senior lecturer in the Department of Aerospace Engineering at the University of Bristol. I have been a faculty member since 2012. I actually graduated from the same university with a master's degree in aerospace engineering in 2004, and I completed my PhD in 2009, where I was looking into the nonlinear stability of autogyro rotors. Perhaps during my master's and PhD, that's where my interest in rotorcraft started. And since then, I've perhaps accumulated expertise in the rotorcraft aeromechanics and rotorcraft aeroelasticity for over perhaps 16 years, combining both numerical techniques and experimental wind tunnel testing methods. I have an interest in nonlinear dynamics of rotating systems and oscillating systems, also interest in rotorcraft aeroacoustics and bio-inspired design. I worked closely with Leonardo Helicopters, former Augusta Westland at the Augusta Westland University Technology Center between 2008-2012, where I was trying to embed and develop some novel techniques within Leonardo's in-house codes. I am currently a principal investigator on an EPSRC research grant, trying to develop a novel modeling framework for rotorcraft dynamics. This is part of a bigger vertical lift network project called Mentor. I am one of the founding members of the UK Vertical Lift Network. This is a network of academic universities, academic partners, and industrial partners chaired by Leonardo, where we try to collaborate to promote research and various activities related to rotorcraft at the UK level. Here in Bristol, we have a good-sized team of academic staff and researchers working on various aspects of rotorcraft dynamics and aeroacoustics. And on the teaching side, I teach rotorcraft aerodynamics and design. And that's pretty much me, and I look forward to your questions.
Thank you very much, Jamal. Okay, our next panelist is David Rolfe. He's a pilot with the London's Air Ambulance Service. David.
Thank you, Jonathan. Yeah, my name's Dave Rolfe. I'm a pilot with London's Air Ambulance and also a safety manager. And I've got just over 20 years worth of flying commercially, helicopters commercially. Although my joy and passion for aviation started at a very young age, I grew up in northwest London, so I was underneath the approach paths to a number of small airfields and watched helicopters and aeroplanes there. So from that, joined the cadets, and then after joining the air cadets, went and did my PPL when I was about 18. All fixed wing at this stage though. I then went to Manchester University, did an aerospace engineering degree, and got some more flying from the University Air Squadron. On graduating, I decided I wanted to continue flying, but couldn't quite work out a way to do it. So I then got to spend 2 very enjoyable years at British Aerospace in Wharton, working as a flight test engineer. I got to work on the Eurofighter Typhoon, the Hawk, and Tornado projects, and that was a really good grounding in the engineering side. But I decided I had to get on with flying, so I then went to Oxford Air Training School and did my commercial helicopter license. After qualifying, went up to Aberdeen and spent 7.5 years there flying offshore, flying Super Pumas. Now, it wasn't all out of Aberdeen. I was very fortunate. I got to spend 6 months flying in Australia into the Timor Sea. And then also every now and again, we got to do some slightly more interesting things like fly people into Silverstone. And also I got to spend 3 weeks flying around the candidate for the 2005 general election. But then I decided to come back on shore, flew for the police and flew for the Chiltern Air Support Unit, flying for Hertfordshire, Bedfordshire and Thames Valley Constabulary. That was great fun. And then moved to spend 2 years flying corporately. The corporate flying was really interesting. We got to fly around the UK, in Northern Europe, but also I got to spend a year operating off the back of a super yacht, which was a completely different way of operating. After that, I got to come back on shore and join London's Air Ambulance, and at present I fly the 902 Explorer. Not only with the flying side, we get to take a trauma team to the side of people in some pretty serious situations. And for me, it just demonstrates the benefit of rotorcraft, not just moving people around, but also getting people to really difficult to reach areas. I have to say, I feel really fortunate. I've had a really varied flying career, but I've also had the opportunity to get involved in some of the technical side, being a technical pilot for the AS332 Puma, the CHC, and also in the safety role now. It's just great to be able to collaborate with people not only in the rotorcraft side, but also across the whole industry, looking at ways to improve safety. So I have to say, as far as I'm concerned, rotorcraft is probably one of the best things I could have done. I'm still really enjoying it. Thank you, Jonathan.
Excellent. Thank you, Dave. And our final panelist is Simon Stacy. So Simon is the Technology and Capability Champion and Active Rotor Program Leader at Leonardo Helicopters. Over to you, Simon.
Good evening, everybody. Yes, thank you for that introduction. Firstly, I'm the current chair of the Rotorcraft Specialist Group, and I'd like to again echo the welcome that Jonathan extended earlier. On the Rotorcraft Specialist Group, we're very keen to propagate the availability of learning on rotorcraft, to raise the profile of rotorcraft. Initially, we thought we'd be doing this in the context of a presentation just at Bristol University. Thanks to COVID, we've actually given us the opportunity to widen this presentation this evening. So I do hope you all enjoy it, and I do hope you all benefit from it. I've seen some of the participant lists, so I'm hoping we're going to get some great questions. I work for Leonardo Helicopters, formerly Leonardo Westlands, GKN, etc., etc. Westland Helicopters is the company I joined back in 1989. And since that time, I've been doing predominantly R&D work. I would describe myself probably as a generalist engineer. I've therefore had a chance to do an awful lot of different things, from materials to radar, and I've worked with more than one of the people on this call this evening. Most notably, I guess, I was able to run the British Experimental Rotor Program in its fourth iteration, which finished up back in 2006. And now I've been able to expand my horizons again. I'm currently looking after an active rotor program, but at the same time, I'm starting to champion hybrid power and autonomy. And for me, as a guy who was used to just making and breaking pieces of structure in an R&D environment, that's a great extension. Rotorcraft is a brilliant sector to work in. It is so varied. And in the UK, we're particularly lucky in that we have the complete life cycle of the platform from concept through to manufacture. So I hope everybody enjoys this evening. Think up some good questions. If they're really good questions, we'll make sure the academics answer it before the rest of us. Thank you very much.
Thank you very much, Simon, and thank you to all the panelists for providing a brief introduction. I think you can appreciate what a wide range of experience we have here, from large and small industry, from being a pilot through to academic and at different points in the career as well. So I think we've got a really broad range of experience. So some of you have already started submitting questions. Please, can you keep these coming in, because otherwise I'll have to dream up the questions, which I have done so don't worry, panel. You're going to be kept busy for the next hour and a quarter. So first question to all of our panelists is, what do you think will be the next major advancement in rotorcraft over the next 20 years, and how will this affect the segment of your industry? Bianca, over to you.
Me first, yes. So for me, I think climate change, it's probably the greatest challenge facing the aerospace industry today. And city congestion across the world is reaching critical levels. And with that being the case, the push to green electric aircraft is going to be a key part of the solution. The problem is that electric rotorcraft are currently limited by the battery technology that we have. Lithium ion is reaching a plateau in its capabilities, and the promise of alternative solutions, they're still in their infancy, really. At the moment, there are a couple of front runners, lithium metal, lithium sulfur, and solid state technologies are rallying really for commercial use. These technologies are currently reporting specific energies between 300 and 450 watt-hours per kilogram at cell level, which is notably better than their lithium-ion counterparts. And in addition to that, they're also non-flammable. They're able to fully discharge, they can survive punctures, and they have long shelf lives. But they all have kind of a common issue, and that's cycle life. So currently, lithium sulfur batteries can only charge and discharge fully 200 to 300 times before their full charge is only 80% of its original value. And a lithium battery, by comparison, can do 1,500 to 3,000. So it is a long way off. And because of that, there's a bit of a flaw in their green profile, because until these batteries aren't really recyclable yet. And until we get to a point that they are, it's sort of like we're in that middle state at the minute. And this really barely scratches the surface of all the elements that contribute to the current battle between aging lithium-ion technology and the new chemistries that are trying to break through. Batteries for rotorcraft are particularly challenging because they have a high power that they demand. And by comparison, the low energy discharge rate required by light aircraft is a far easier thing to do. Increasing the power of the battery also decreases its specific energy as well as its cycle life. And it's entirely possible, even likely, that we haven't yet discovered the chemistry that we need to power the future. The advent of advanced energy storage technology capable of supplying the power demand needed for rotorcraft and also at affordable prices is going to be a game changer. And if you couple this with the autonomous development strategies currently on their way up, the applications for rotorcrafts are going to expand on a massive scale. Suddenly it will become possible for thousands of people to become private owners or users of these aircrafts without pilot license or insurmountable running costs standing in their way. And essentially this is going to open up a whole new market, which could change the way that rotorcraft design works today. There will also be a number of major advancements in rotor noise and aerodynamic analysis and simulation technology, as the vehicles in this new market sector are going to need to meet much stricter standards for noise in urban areas. Duct technology is going to need to be optimized to provide high levels of safety and increased performance at the same time. And the industry is also going to be forced to consider obsolescence on a recurring basis to create modular designs which can deal with the fluctuation in battery chemistry that's going to happen in the next 20 years. So it's going to be an exciting time to be in the industry, not least because the challenge of certifying all of these different technologies all at once is going to be a challenge of a generation, really.
Excellent. Thank you, Bianca. I like the phrase saying it's an exciting time. I keep telling my students it's okay. At the minute, we're in quite a challenging time, but aerospace as a whole, I think it's extremely challenging. Brett, what's your view on the future?
So I guess the most important thing that I can see at the moment is really the enablement of different configurations from distributed electric propulsion. So something that Bianca was talking about just before. So really, I guess the kind of traditional rotorcraft configuration hasn't really changed a lot up until fairly recently. Although I guess the people that are a bit more experienced in the industry will have come across the VSTOL Wheel of Misfortune, where all of the different concepts from the 50s, 60s, and 70s, where they pretty much tried to attach wings to jets to everything else and seemed to try all kinds of stuff, and not much of it really panned out. There was a lot of mechanical complexity, cross shafting across all kinds of different weird geometries. And really one of the big constraints there was the propulsion system. So with the recent advances that have been outside of the aerospace sector in electrification, in batteries, in high voltage distribution, in electric motors, that's really started to open up different aircraft architectures. And I would say that, considering I'm in the aircraft architecture team of Vertical, but I really do think that the different configurations that we can try now and actually make work really kind of come down to the distributed electric propulsion, so that you can actually have a fairly static distribution network, that you don't have to have complex mechanical systems anymore. And that lets you start to look at lots of different configurations. So this has kind of turned into a bit of a Wright brothers era for rotorcraft, which I think is pretty exciting. When I finished my degree 16 years ago, I thought, well, maybe I'll get to work on 2, maybe 3 new aircraft programs in my career. At Vertical, we're on to our 3rd new aircraft, full-scale flying test aircraft in 3 years, which is pretty exciting. So to give you kind of a scale of the plethora of concepts that are out there at the moment, the Vertical Flight Society keeps a nice record called the Vertipedia, which they keep track of as many different concepts as they can, and they list about 900 vertical takeoff and landing and short takeoff and landing aircraft. If you then look at the eVTOL aircraft, so the electric variants, there's about 300 different concepts out there at the moment. So if you go from kind of the 1920s of the Juan de La Cierva, the early autogyro, up to maybe 10 years ago, when Leonardo did their Project Zero and wowed the world. So 900 in that big space of time, and 300 in the last 10 years. Now, concepts are easy. It takes you 10 minutes to sketch something on a piece of paper. Building the aircraft and flying the aircraft is a lot more difficult. But actually, that's where I see there's going to be big changes pretty soon, and then continuing to evolve over the next 20 years, particularly as the electrical system and the battery system starts to enable even more capability of the aircraft. So I really think that's kind of the biggest change that I can see that's happening now, and is going to continue to happen for the next decade or so.
Thanks, Brett. And one of the points to make with the things like urban air mobility is there are it's a bit like 1910. There are hundreds of companies all around the world trying to develop, not just rotorcraft, but all bets are off as to what the future is going to hold. So, as Bianca said, exciting times. Jamal, if you can remember the first question, major advancements in the next 20 years.
Yes, thanks, Jonathan. Yes, I think I echo what Bianca and Brad said. I think this is I think I call it probably a golden area for rotorcraft development. And I see that from various sides, but mainly from the configuration and the technology advancement sides. So from the configuration side, as Brett mentioned, we will see the development of new and novel rotorcraft concepts, such as those for urban air mobility, or even for other missions. And really, I can't wait to see the amount of innovations in this area to deal with all the new challenging kind of issues and challenges spanning from the electric side to noise to dynamics, etc. I think we will also see some clever use, hopefully, of drones in domestic and industrial sectors for different missions. And what will be interesting to see is the development of the certification and regulations that will allow these kind of types of vehicles to operate. And the third thing from the configuration side, I think this is something that we've been looking for, is the operation of the fast helicopters, like the tilt rotor and the compound helicopters, specifically in civil markets operations. From the technology side, amongst many others, the two things I think in the near future that we will see is the electrification of rotorcrafts for greener transportations, for greener industry. We've recently seen on the news the Rolls-Royce development of the first or the fastest electric aircraft. So it will be nice to see when the rotorcraft, electric Rotorcraft is going to happen. And we will also use or see the use of autonomy, either full autonomy or partial autonomy, to help the pilots or to reduce the workload from the pilots. Something like hazard detection, for example, that would be good. So I think there is again, iterate. I think it's an interesting era. It's interesting time to see kind of interesting configurations and interesting technology.
Excellent. Right, David.
Hello. Yeah.
Dave,
No, I
sorry.
think hello. Yeah, I think from an operator's point of view, the one thing that's been limited helicopters for years is speed and range. If you look at a helicopter from the 60s to now, we really haven't changed shape much. We've maybe changed the way we do our anti-torque with things like fenestrums and NOTARs, but actually retreating blade stall has caused us a big problem, and we probably can't do much more than 180 knots at best. And we're really good at doing short distances and getting people into tight spaces. But most of our users would love to go further, from the corporate owner who wants to go from their private residence somewhere to maybe the center of a town, to search and rescue or ambulance jobs where it's really critical to get those people as quickly as possible to where they need to go to. So for me, I think the really exciting times is seeing the faster helicopters and helicopters that can go further, but these may not look like the helicopters we expect. I mean, even in the past few years, we've seen the X3 from Airbus, which is going to potentially turn into the RAeS program. We've seen the X2 from Sigorsky, which is turning into the Defiant. And these compound helicopters or concepts are just going to give us the speed and the range that we're looking for. And also, hopefully, we're just on the verge of seeing tilt rotors come into service operationally again. There, you're getting the benefit of a vertical takeoff and landing aircraft, but also the speed of a turboprop. So it could just make a massive difference. So for me as a pilot and as an operator with customers and users in different domains, I think it could be really good. The other thing that's exciting about helicopters is we can land and take off anywhere, but we want to do it in any weather. At the moment, we're still really tied in to maybe the fixed wing mentality, but with the opportunity with GPS developing, the ability to do a point in space instrument approach anywhere in the world, the technologies around that I think are now developing with the terrain mapping, GPS databases, that we'll be able to do that. So I think we can just see the extra flexibility of rotorcraft developing. A couple of things that we need to be aware of is the increase of this urban air mobility, which would be really good. And it's just working out how to have the technology to see each other so we can really make the most of the airspace rather than having to restrict ourselves by defining different areas where we will operate. So the better we can do that, the brighter the future.
Brilliant. Thank you, Dave.
Yeah.
And final answers to the first question on technologies for the next 20 years, Simon.
Thank you. Some really interesting responses there, and I guess it's ironic, therefore, that as somebody who spent all his time in R&D might be suggesting that simpler technology might be what lies ahead of us. Why do I say that? What I see coming in the next 20 years is a real step change in the accessibility of vertical takeoff and landing vehicles. So what do I mean by that? We've already talked about the urban air mobility movement. Unmanned air systems is another element there as well. I see those sorts of things making rotorcraft more available to people than before. And what do I see as enabling that? And I've been making notes as we go along. Autonomy. Autonomy is something we've touched upon once. Autonomy for me, the development of, is key. Infrastructure, a point that Dave made, these vehicles will need to have an infrastructure of operation, not just where they land and take off, but the environment within which they fly, close to each other in a congested environment beneath the 10,000 feet. And also the cost of operation, the reliability and maintainability. That's going to be another key element that requires the application of new technology, but it may not be the ultimate performance technology. The challenges we may face in the next 20 years will be to come off of that performance roundabout and look at those other attributes that make the aircraft more available to be used, to make it more usable. Autonomy is going to be an enormous deal. Looking critically at aircrew work at a time when the aircraft will get more complex, and the operational environment will get more complex. If autonomy does not come on with that and keep pace, then we will not be able to unlock all of that capability. The infrastructure side of things, for starters, yes, this does refer to how you operate the aircraft from where and to where, but it also talks about how you're controlling that airspace, how the aircraft are relating to each other. We talked about the particular navigation options that might become available. The cost of operation, the reliability and the maintainability, this is where it becomes interesting, because this sort of revolution has already happened in the fixed wing community. If you look at how fast you flew from London to New York in the 60s versus today, it's slower today. Why is it slower when we've got higher tech? Well, we've decided to come on to a cost operating point that makes it more viable and makes it more available. And I find that interesting. You know, will we see the same sort of thing in rotorcraft? You know, we've talked about what we'll see in urban air mobility. Are those the sorts of reasons that will enable urban air mobility and vertical takeoff and landing vehicle use extend more into the rest of the population? So those are the main changes I've got.
Thank you very much, Simon. So sort of the follow on from that, we've talked about novel configurations and different types of rotorcraft. Tilt rotors, what do we see a future prospect? I mean, it's something that people have worked on for quite a number of years. Jamal, what's your view on tilt rotors? Are you mute?
Yeah. So I'll give my my side of the answer from the academic side. And so yes, I think the tilt rotor program has been active for a number of years now, and Leonardo in particular trying to get the AW609 kind of through, I think, all the certifications and the to get it operated. Perhaps Simon can touch on that later. So I think from the civil operations side, I think the tilt rotor is still an advantage for transportation. Of course, it has been used already for military purposes, and I think there is a key advantage to the tilt rotor compared to other types of configurations. So I think yes, when exactly we will see a massive use of tilt rotors, I don't know. I think anytime we design a new configurations, there is always a challenge to get everything certified and address all the issues associated with new configuration. So I think that's perhaps one key that's delaying the use of tilt rotors.
Okay, and Simon, do you have anything to add on that about tilt rotors?
Yeah, all valid points. Being the first to market of a type of aircraft is always going to be with its challenges, not least because in addition to the technical challenges you face, you face the regulatory challenges, as Jamal rightly points out. I view tilt rotor as very much at the beginning of their Cambrian period. Brett mentioned earlier how we're entering this sort of explosive evolutionary period, and of course, what have we got on the doorstep? We've got a more electric aircraft, and I see more electric as offering significant benefits to tilt rotor configurations. If you look at tilt rotors configurations at the moment, if you go read the conference papers, awful lot to say about the challenges of wing design, for example, because you've got to fit so much in today's wing configuration. So what might that more electric aircraft do for us? What might an electric powered rotor that no longer has transmission shafts running through a wing do for us? The aerodynamicists logged on here this evening will be delighted that they can finally have the aerofoil on that wing that perhaps they'd hoped for, which is partly dictated or challenged at the moment by the amount of mechanical systems that run through it. So yeah, tilt rotors are fascinating aircraft. They will have their niche in the market. How big that niche is obviously remains to be seen, because the aircraft, our particular aircraft from Leonardo, the AW609, has yet to be launched formally onto the market as a certified platform. but it will illustrate the value of fast rotorcraft, and fast rotorcraft is a big theme. We can see fast rotorcraft is a big theme in the US in the military context, and we're going to see that cascading into the civil context as well. The question is, what will the configuration winner be? Lift compounding is a great way of reducing the load on the rotor, but it brings with it aircraft footprint challenges and so forth. So yeah, interesting times for tilt rotor ahead.
Okay, thank you. I think I'll move on to the next question. There's been a number of questions from aspiring pilots or young people who wish to work in the rotorcraft industry. And so the next question to the panel is, do you have any advice as to how to progress the career, or where they ought to, apply for jobs or placements and things? So Dave, perhaps you can start.
Yeah, absolutely. I think the key thing is just to get to know as many people as you can. If you're very young, there's a youth organisation you can get involved in, then I'd highly recommend joining the Air Cadets or the equivalent in your wherever you are in the world, and then just getting some experience. So I certainly found going to talk to people in the industry really good. Most pilots, and I think most of the panel will agree, are more than happy to talk about flying. So if you can find someone who's willing to talk to you, then they're more than willing to give you advice and let you know how to do it. I think the other thing is just get involved wherever you can. I mean, I was really fortunate and really valued the experience I got from the engineering side as well as the flying side. You don't have to have an engineering background, but it really helps just to get a better understanding. So I think key thing is just try and find somebody in this industry you can talk to, and also make contact with people like the Royal Aeronautical Society. They've got a really good booklet on how to become a pilot, and that will certainly give you ideas from starting off as an instructor or joining the forces. There are many different ways to become a pilot, but just, yeah, find people and talk to them about it, I think, is the key.
Okay, Bianca, you're on mute.
If it is that you want to be an aerospace engineer, there's kind of two routes, and the one is that you go to university and you study aerospace, mechanical, or even electrical engineering, and that really gives you a really good background. It also gives you flexibility. If you're not sure exactly what it is you want to do, then doing a degree kind of gives you that sort of buffer of 2 or 3 years where you can kind of figure out what stuff really excites you. The other option is going to be an apprentice. So Leonardo, for instance, same with I think Rolls-Royce and the other big companies, offer apprenticeship schemes as well. And if you feel like you're more hands-on, you can do that kind of thing. You can also get your degree funded through them. I know Leonardo does like a degree apprenticeship scheme where I think it's a 6-year scheme, and you do your degree at a local university as well as getting practical experience, which is really good as well for getting chartership and getting interested. But really the best advice I can give you is just be passionate. Anything that excites you, even outside of your degree, just go and do it. There's like robot wars, that kind of thing, just go and build things, have fun, and yeah, and you'll make it.
Excellent. And Brett, do you have any ideas?
Yeah, so I guess one of the suggestions I would have is to try and differentiate yourself and actually try and help the people that you're going to apply for jobs with understand what motivates you, what drives you. As Bianca said, there's lots of different ways that you can do that. That doesn't have to be just sitting in a classroom, getting really good grades. It can be going and doing something that you enjoy that is related to engineering or science or technology. So for the quite attractive jobs, there are normally lots and lots and lots of applicants. So to actually kind of get your foot through the door, you need to show something a little bit different. And that can be some hobbies, it can be a project that you've done at home. Try and bring yourself along when you're trying to get that first foot in the door, and I would almost guarantee that what you think your first job will be like is not going to be like that. So have a go. Actually, there's quite good mobility in the aerospace industry, so don't be afraid to have a go. And if it doesn't seem like this is the perfect job, you probably don't exactly know what the perfect job is yet until you've tried it. So have a go, and you'll learn, and you'll iterate, and you'll take that kind of approach, I think.
Fantastic, right? Get out there. You know, you as you say, just sitting there and getting your grade. Okay, you need to do that, but getting out, meeting people. When I started my first job at the RAe Farnborough, which is showing my age, my boss was almost insisting that at least once a month I should be out meeting people and getting known. And as people at the university know, that the collective noun for professors is an absence, and I'm quite good at that. Next question, Simon. This is go to you first, then Jamal. We're obviously in very difficult times with COVID, but also, you know, a year ago I was getting fed up with Brexit, and that would be a breath of fresh air if that was the only thing to talk about the effects of that. Do you have some ideas as to, you know, obviously it's having a big effect, but are there opportunities that are coming out of the whole situation we're in? Simon.
Yes, absolutely, absolutely. Let's begin with COVID. What does COVID do? COVID has forced a reset on the industry, really, to which has resulted in more flexible working practices. You know, the ability of people to be working from home means you have greater ability to get hold of people. And in the last 6 months, I have managed to get more people around a virtual table quickly to hold discussions on new concepts, new ideas, and not just from within Leonardo, than I would possibly have done. It's encouraged us to change the tempo, to think less about, well, you know, can we get 5 people and all go up in a car and meet X, and more to say, can we all talk tomorrow? Is it you know, do we miss that human part of it? Yes, I'm sure we do, but you know, we can all get used to that. Other industries manage it in this way. In terms of Brexit, there is always opportunity in uncertainty, isn't there, really? And if one thing I would say that I'm seeing in the media, as well as through my own work experience, is that Brexit has brought a realization on the UK government of the need to support industry, to generate those tax revenues to be able to keep the industry running. And again, if COVID has shown us one thing, is that we have an alarming reliance on our ability to sell people sandwiches and ice creams. You know, we need to drive industry to generate those tax revenues.
Thank you. And Jamal, I was going to next.
Yeah, I think I echo what Simon said, and it's always the case where opportunity is mixed with challenges. It's always the case wherever you find challenges, there is always opportunity there if we look in it. And certainly the COVID situation has allowed us to think in different ways. And for example, from the research and teaching side, we've been able to initiate and form various collaborations to try and tackle various challenges or various research problems. Coming back to the Rotorcraft side, we're looking at disciplines for or problems associated with aircraft noise, helicopter noise, vibration, dynamics integrations associated with these urban air mobility concepts. On the teaching side, we're trying to see how we promote the Rotorcraft field to a national level, but also because of the current technologies of this web conference, and we're able to share these seminars at an international level. As an example, is this webinar, but other activities that we're doing as part of the UK Vertical Lift Network, as well as the Royal Aeronautical Society Rotorcraft group, is to see how we can promote Rotorcraft, create CPD courses, create training sessions. We're doing, at the moment, we're having some UK VLN workshops that are free for the next couple of months. Check the website if you want to book in or join in. So yes, so again, as I said, there's always opportunity mixed with challenges. So it's just a matter of knowing what to do and finding your niche.
Sure, indeed. In all times of adversity, there are always opportunities, but you've got to go and find them, and that's at all levels of industry or as individuals. Okay, next question may be a bit contentious, but with the onset of automation, are we going to see the demise of the pilot? Brett and Dave can have some more time to think of a rebuttal to that. But Brett, what are your thoughts?
So my brother is a commercial pilot, so he would be very upset if he heard me say yes. Now, I think that there is a long-term vision for particularly urban air mobility, where there is a large scale up to the number of aircraft, and actually partly for that reason that you have such a high concentration of aircraft in a congested area, there will need to be a lot more automation moving eventually towards autonomy. That is not going to happen quickly, particularly as has been mentioned a few times on this panel already. The challenges for us are about introducing an entirely new vehicle type that is electric, that has to meet by far the most stringent rotorcraft safety requirements that have ever been in the EASA SC VTOL set of requirements. There's so much novelty already in the aircraft that the pilots are going to be on board, and they're going to be a key part of that safety system for quite a while to come. Now, as you start looking out in your time horizon, and predictions are always going to be wrong, but there will need to be a move to more automation and autonomy, but I don't think that's going to happen, not in the immediate future anyway. And actually, because you're going to be looking at the number of aircraft scaling up so rapidly, you might find that actually there is an extra demand for pilots as you go through that transition of the number of aircraft, of rotorcraft increasing before you can actually get to full autonomy. So I don't think it's bad news at all for pilots. I think it might actually be quite a good outlook.
Brilliant. Dave, right. And then Simon after Dave.
So I would tend to agree with Brett, actually. I think automation is not something to be feared by a pilot, but actually something to be encouraged. I've heard a very good talk a couple of years ago from Sigorsky about the matrix system, and I like the way they talk about that. They talk about optionally piloted. So, as you know, pilots are human beings are very good at dealing in situations that are changing very dynamically and are not quite as expected. But machines are brilliant at doing routine tasks really well. A machine will fly an instrument approach much better than even the best pilot. So for me, I think it's just watching the collaboration between pilots and automation as they come together. And I think, as Brett said, I reckon we've probably got a couple of generations of pilots left before we go completely autonomous. But as I said, it's something to work with rather than work against. I think it's will be a positive step forward, actually.
Brilliant. Simon wanted to make a point?
Yeah, just to echo, really, you know, if we are on the threshold of a Cambrian period of rotorcraft, as we all, I think, believe we are, then right now the consensus is that we will be needing more pilots, not less. The job of that pilot will change. He's going to be less of a stick and rudder man, as they might have said. But the pilot's job will still be there. I find it very interesting. If we look far ahead into the future of autonomy, at what happened on the recent Dragon 3, I think it was, sent up to the ISS, where basically the two crew in that spacecraft really were not supposed to touch anything for the entire mission profile. Once it was in orbit, they then, however, conducted exercises to understand how that vehicle would behave, amongst other things, in the event of failure modes. And this is where it all starts to get exciting, and this is where we rely on the human to be able to catch it. Way into the future, might we see a change in that piloting load? As I say, his job will change, but I think he will quite often still be there.
I always worry that, you know, I've sat on planes and they've announced, is there a doctor on board? I don't want to be sat on a plane and they say, is there a pilot on board? But hopefully that's past my lifetime. Okay, next question. Several people have asked about equal opportunities for men and women, and I guess across the whole diversity in the aerospace industry. Do the panel have comments on how that has changed, and are there changes that still are needed? And Bianca, I'll go with you first.
Yes, no, I think the industry is really supportive now. I think there's a real push for everybody just sort of wanting just to get a really nice, diverse group of people, everybody with different ideas coming together. Because I think the more diverse a group of people you can get together, the more exciting ideas you can get. But yeah, no, it's a really supportive environment. Just believe in yourself. And you'll get there. And I mean, that's the case no matter what your background is. I think the kind of aerospace industry in general has changed very positively in the last 20 years, whatever it is. And I think we're really just on a upwards trend at the minute. I think at my university, it was probably 1 in 10 for girls, something like that. But that's still a lot better than what we had before. And yeah, generally, I'd say it's a really nice atmosphere. Everybody's very supportive, and don't be afraid.
No, sounds good. That's for everybody, not just young
Yes.
ladies. Right, Jamal,
No.
from a university viewpoint, how do we get more representation across the whole D&I spectra?
Yeah, so the university, at least Bristol, and I'm sure many other universities, the theme of equal opportunity is something fundamental at its core. So we do our kind of best to advertise for it and to push for it. Yes, different disciplines crossing between engineering to biology will have different proportions of people, but still we're pushing. So in engineering, we have various, I think, workshops kind of targeted at, for example, genders that are less represented. And this is from the student side as well as from the staff side. So it's not just the kind of at the student level. So it's something that is at the core of the university kind of mission and vision. So we do our best to make sure, and it also actually works better for the team. Every time when we have a diverse team, I think there is a much more opportunity, bigger opportunity for producing something novel and advancing the knowledge from an academic point of view.
Excellent. And Dave, have anything else to add from piloting?
I have to say, yeah, from over the past 20 years, I've definitely seen a big change as well. It was very much a male-dominated industry when I joined, but I've just seen more and more people coming in, more female pilots, and just a real variety, and also the attitude change. So from some of the guys I may have joined with 20 years ago, not my age, but the old and bold, as they would say, maybe one or two had some slightly outdated ideas, but I've certainly seen over time, and having flown with a number of female pilots, most people, certainly my generation and beyond, know that we are all as capable of doing the job as anybody else. And that comes from opportunities to get into flying. I think the biggest barrier to becoming a pilot is financial these days. And if you're not willing to join the armed forces, it's trying to find a financial way in. And I was really fortunate when I did my training, the government were running an MVQ scheme where you could get 25% tax off and you didn't have to have an instrument rating. I think it's really imperative for operators to try and find ways of bringing people into the industry. Bristow's used to run a sponsorship and will periodically do that. But it's just if you want to get a bigger diversity of people actually flying the machines, you need to find ways of giving them better access. But I think things are moving in the right direction.
Excellent.
If I could just add last thing.
Please do, yes.
Is that the graduate scheme at Leonardo and generally like the company, they give you a lot of opportunities to do STEM outreach. And you can do that with the Royal Aeronautical Society as well from university. And it's really great, like you get to go into schools and go with kids, like, you know, in those formative years when they're sort of 10, 11, and boys and girls are still very much the same, you know, and you just get to go into the schools and do exciting presentations and sort of like help them build cars. I'm actually doing this, we're organizing this cool aeronautical thing with about 500 kids in the local area. And we're doing it all virtually. But sending out sort of kids for electric cars that the kids are going to build. and doing some bridge building activities and all that kind of thing. And that's all made possible just by local support and from the Royal Aeronautical Society. So really just get involved. There is a lot of stuff going on right now.
Indeed, and I think a lot of the STEM, and it's not just educating the kids, it's the teachers. A couple of years ago, I was helping out the Aero Society at a vast event at the National Exhibition Centre, and I had to walk almost the distance of Wales to get from one end to the other, and I passed a coach of, I guess, sixth formers jumping off, perhaps not even that, 14-year-olds, and the teacher, who was a lady, said, okay, technical engineering stuff that way, boys, hairdressing this way, girls. And it's a terrible story, but it's something we still need to do. So again, via the Aero Society, or there's lots of different ways we can all get out the message. And what is an engineer? What exciting things do we do? You know, everything we've been talking about this evening has been just sort of some of the fantastic opportunities that there are. Okay, one of the things, I think, moving on to the next question, is that, you know, from an environmental viewpoint, and several of you mentioned that in your opening statements, helicopters are one of the least fuel efficient and also the noisiest means of transport. How is the industry going to adapt this? Perhaps Brett, and then Simon, then perhaps Jamal could answer that.
Yeah, so I guess the urban air mobility market is actually not new and has been tried before, even in the UK. And one of the, or a few of the reasons why it didn't actually work out were cost, noise, and an environmental impact. But actually now, with the VA1X concept that we released publicly, I believe a few months ago, which is an electric tilt rotor, you can actually start to get incredibly efficient aircraft, and because of the distributed propulsion, it lets you actually have the required level of safety, and really then you can target the noise. So one of the things that lets you do is really start to distribute the propulsion, keep the tip speed of your rotors down, and that really means that our vehicles and other vehicles that are being designed should be substantially quieter than existing helicopters, to the point where NASA has run some trials of actually seeing how much of the noise from these vehicles will be able to blend in amongst existing motorway noise in some American cities. So that's the kind of change, big step change that you're talking about when you can start to architect your vehicle differently. And in terms of efficiency, so the move to batteries as an electric power source means that actually we can source our energy from wherever we choose in terms of making sure that it is renewable energy. But actually, from our initial behavior of our vehicles and our simulation, we should be able to get the energy usage for an eVTOL close enough to what you would actually have for an electric road car, which absolutely sounds crazy, but you're flying point to point. You're not talking about flying at incredibly high speeds, but you have a very, very efficient aircraft that is optimized for a particular mission. So actually, the new eVTOL aircraft, particularly tilt rotors, are quite efficient. Really do address the kind of fuel efficient or inefficient and noise as two of the big detractors of conventional helicopter designs.
Okay, thank you very much. Simon, you have a viewpoint?
Yeah, it's something that is the continually vexing the rotorcraft industry. Vectoring a column of thrust is a really expensive way, energy-wise, of keeping you in the air. And what can you do to reduce the amount of energy you expend there? Well, you can optimize the rotor, and that's what the BERT4 program was all about. That's what active rotor programs are all about. But ultimately, as Brett has alluded to, one of the best things you can do is lift compound a rotorcraft vehicle so that in the air you're getting wing-borne flight as well as lift from the rotor, so that you can offload the rotor. So that's really probably the most powerful thing you can do. And then you can start to look at your energy source. Again, as Brett has touched on, we can have a look at the electric side of things and how we generate the electric side of things. As Bianca touched on in her opening speech, battery technology is not going to save us anytime soon. There is not enough rare earth material on the planet to meet everybody's demand. So we will have to look in other directions. And the ability to burn hydrogen in an internal combustion engine is a really interesting one that needs more credence. Finally, touching on the noise point, noise in rotorcraft is an interesting one because they are not as noisy as some would have you perhaps suggest in some circumstances. Yes, they can be very noisy in some approach paths, for example. But the trouble with rotorcraft noise is it's less easy to measure it as intrusive. It is more human qualitatively assessed as intrusive. And I read an article earlier this year where a rotorcraft operating base in the US had shut, and they continued to receive complaints about rotorcraft noise for 4 months after the base had closed. So, you know, what's going on there? There was more in the perception than there was in the reality. But yeah, there we go.
Fantastic. Jamal, you have a viewpoint?
Yes, I wanted to add something, which is, first of all, we should always remember that the helicopter provides a particular set of missions that other vehicles can't provide. And when you look, for example, at the search and rescue missions or HAMS missions, you always try to remember that these vehicles, the rotorcrafts, help to save lives, and therefore the fact that they exist actually is good. Now, yes, we do want to make them more efficient, and we want them to make them less noisy and vibrate less. And for that there is still, and now we're conducting like lots of research programs in the university. For example, we have a set of research programs looking at propeller noise, particularly looking at the use of this urban air mobility and electric vehicle applications or distributed propulsion systems. We do want them to see how we can reduce the noise coming from the propellers or the rotors, as well as how we can kind of dampen the noise using some clever materials, metamaterials, etc. Simon mentioned active rotor programs, and those have been used, like, for example, blades with active flaps to reduce noise in the past, as well as to use them for reducing vibration. So there is still a good amount of research that needs to be done, and this is a continued development that we will still have to do and join efforts from both academia and industry.
Thank you. Right, we've got about 15 minutes left. So if you've got a burning question you haven't asked yet, please fire that in. Next question, though, is a bit more on sort of personal reflection. What is the biggest engineering challenge you have faced in your career? Dave?
I think probably one of the biggest engineering challenges as an operator is that you often operate remotely from your engineering base. So it's trying to keep an aircraft flying and to keep all the complicated technology, as Simon has brought up, going. So when I was operating the aircraft off the back of a yacht, we'd have to look at things like how we get that aircraft from A to B, removing blades, having an engineer with you only every couple of weeks. So it's working out how to maneuver and get an aircraft to where it needs to, keep it operating with limited engineering support. But I think also it's just how to integrate stuff. So for me as a pilot, I always want to have the latest, most exciting gadget on my aircraft. But the trouble is, it doesn't always give you the benefits you want. If you're putting a new bit of kit somewhere, it's the way it reacts. So for instance, I've been involved in having traffic avoidance systems put in an aircraft. And as a pilot, it's great because I want to be able to see other traffic, but then it's making sure that it doesn't interfere with the other equipment, that it doesn't pick up your own transponder. And it's just really working out how to integrate new bits of kit that are going to be effective. But I also enjoy the challenge having a flight test background. I enjoy the challenge of trying to give an operator's perspective, but also try and problem solve. So I think it's probably remote operation, but also operating and integrating new bits of kit for me.
Okay, thank you. Right, Bianca?
As I'm still sort of in the beginning of my career, I'd say that having managed to get through uni and get my first is probably still one of my big challenges that I overcame. And like, yeah, just doing like the big research project, both because I mean at Bristol you have two, so you have a research project and you also have like a group project with 8 people, and as anybody can attest to, working together with 8 people on something that you all want to do well at is always very stressful. So I think, to be honest, group projects was definitely one of the biggest challenges. The design project that I did this year with a group of the 8 graduates from Leonardo, also very challenging, because all we had was like a 2-page, 3-page set of specifications, and otherwise it was literally up to us from scratch. And you know, just without any support, just actually being able to sit down as a group and sort of decide all of these things that you know, other startup companies like Brett's are doing. You know, it really gives you an idea of just what great accomplishments they've already made. And I'd say just in general, that kind of thing, greatest challenge so far.
Fantastic. And Brett?
It might sound a little bit trite, but I guess the biggest engineering challenge for me is actually the one we're in now. I mean, it's a big challenge that we've bitten off for us here. We're doing an eVTOL tilt rotor. That is no small mean feat. But I guess the specific bit that is one of the key challenges, I guess, for us is that there are so many different systems within this sort of aircraft that need to be looked at an overall aircraft level, because the battery technology is there and is good enough for us for now, but it means that you're actually really having to optimize all of the bits of the powertrain, all of your flight control laws, all of your structure, everything to get a good aircraft out at the end. And the interactions between all of those different systems, trying to capture them in a pragmatic way that you can make changes and figure out what's going to happen at an aircraft level. That I think right now that we're in the midst of, or we're developing the next aircraft, is the biggest engineering challenge I've come across so far.
Indeed, thank you. Right, another question, interesting one that I'm going to address to all of you. Can you each define one, or what you reckon is the top research challenge for urban air mobility? And are there any silver bullets that could be game changers, or even game challenges, according to the way I've typed it? Simon?
I think there are a number of challenges. When you look at configuration of a UAM, you can see the similarities and you can see the differences. If there is one challenge that I would highlight heading on into the future, as tempting as energy storage is and the ability to meet the green agenda, I would come back to autonomy, because I think to achieve the levels of autonomy that people are expecting will take an approach that differs from that which you see in the industry today. We need to start talking to people, and this comes back to how you get in the industry. We need to start talking to people who do very different jobs and understand how the human-machine interface works in a way that the conventional aerospace mind probably is not thinking. You know, the people that are in the PC gaming industry and people like that, because as these vehicles get more complex, or the operational modes in which they have to perform become more complex, the messages we're trying to get back to the aircrew will become very challenging. We need to understand how to do that, not just because we need new techniques, but of course we'll have the next generation of pilots coming along, you know, and they won't be thinking like I do as an engineer, or Dave might as a pilot. They'll be used to a very different interface to work with. So we've got to tap into that. We've got to change the way we think, and we've got to embrace that, because it'll be exciting.
Fantastic. Jamal, what do you think is a big hitter?
So, as Simon said, there are a number of challenges, but I'm going to perhaps pick a different one, which is which is the design of these vehicles. If you look at, for example, the eVTOL that are listed, that Brett mentioned earlier, 300 different concepts. And then if you want to design one of these concepts, you need to look at the vehicle as a whole. And that's kind of needs to challenge the mentality of the designer. Where do you start? How do you integrate everything? So you need to look into the whole system, particularly for those concepts that have a multi-configuration during a particular mission. So they can hover and then they can tilt their rotors or tilt their wings and then move to totally different aircraft. So the mode of operation during vertical flight or during transition or during forward flight are different, and you need to think about all those aspects in trying to come up with the design and the evaluation of how this aircraft performs compared to other types of aircraft, let alone the certification. That's a different beast.
Brett, you have a view?
I'm going to take maybe an unexpected direction and say, actually, I think it's public perception. That as technical people, we all tend to focus on solving the technical problems, but the whole reason for doing this is to actually have a market at the end of it. There is a lot of work to be done in the public perception of urban air mobility in terms of how the aircraft operate, even for the passengers, as well as for the people that aren't passengers. Simon mentioned before that actually just getting a nice metric for what noisy means is definitely not trivial. So that I think that really there's quite a lot of research that needs to be done to try and not really on a single vehicle, but actually if this is to be an industry with different vehicles doing different things, we need to start getting an idea of how the public is going to react to that, because if that's an adverse reaction, there is no market. And I really think that needs to be kind of emphasized a bit more. But it doesn't tend to live so well in the technical engineering circles when you say public perception as a research topic.
Yes, good point. Bianca, what are your views?
I probably take the obvious one, which is the energy storage, but also the infrastructure that goes with that. Because I mean, the batteries that we have at the minute, the lithium-ion ones, they charge in quite a long time still, and it means people are currently talking about, you know, swapping out batteries and that being the kind of system they want to use. But that's going to be a very complex system, and you're going to be limited by the places that you can put landing pads, for instance, in a city, if that's the method that you're using. So having a battery that can actually charge up in 15 minutes, there is a company, QuantumScape, that says they can do it in that time. Whether they can or not, you know, but yeah. So I think having a battery that can charge in the time that it takes you to land and come back up again, that's going to be a game changer. And I think, yeah, generally infrastructure-wise, a lot of people are hearing about urban air mobility and they're imagining that it's going to be in every city ever. But some cities like London, going to be very difficult to actually get into some of those areas because the streets are small, there isn't obvious landing pads. And I think that's going to be an interesting one because in American cities, they have very wide roads and they have fairly short buildings with flat roofs. So you can see how it's going to fit in. And I think actually figuring out infrastructure-wise how we're going to adapt it to all the cities that are inevitably going to want it and need it, but it's not going to be easy to implement. I think,
okay,
yeah.
Thank you. And Dave, what technology would you like to see?
I think we sort of touched on it earlier on. It's the ability to operate together. It's the technology to see and avoid. It's the automation of working in a really busy bit of airspace. Because if this really does take off, excuse the pun, you know, we're going to be looking at cargo UAVs, we're going to be looking at passenger carrying UAVs, and we're going to be looking at manned aircraft, and we're going to be wanting to put a lot of stuff in a very small space. So it's the way of producing very small but units that allow us to see each other. I think that's the biggest thing. It's bringing the technology. But I have to second Brett. I think probably the other thing is perception, because at the moment helicopters, as brilliant as we all think they are, other people think are very noisy, expensive devices. And actually, it's really just helping to demonstrate to people that it's not a rich man's toy, that it's actually a really useful device. And if we can get that across early on, I think that's really, really important.
So we're coming towards a close. So a final question. So I'm going to ask the panel to be in sort of crystal ball mode, but we've talked quite a lot about urban air mobility. So do the panelists think we're going to see general urban air mobility across our cities, and in what timescale, or do you think that the public will say no, we don't want it, and we'll come back to you in 20 years time and see whether you were correct? Brett, I'm sure you're going to say yes.
How did you guess?
Why not?
No, I guess it's not a panacea. It's not the answer to all of the problems of transport within a city. And people that try and pretend it is are trying to push the hype a little bit too far, which I don't think helps anyone. I think that you are going to see an introduction into particular cities that want it, and depending on which country you're in, more or less of the regulations around the aircraft operations are from a national level or a state level or a city level. So that's an important part of it. So some cities do really want this, partly because they aren't able to kind of retrofit the public transport infrastructure that they would like. That's a pretty expensive task in an established city. So from the location side, I think you will see it only in specific cities, particularly early on. The certification side, that's progressing quite rapidly, really. So we're involved with the EASA and the EuroK working groups on developing the means of compliance for these vehicles, and that's an active conversation that's ongoing now. We're still sticking by our certified aircraft by 2024, which is pretty aggressive, but actually, I don't think you'd have all of the people at Vertical working as hard as they are unless we had a shared belief that we are going to see this. Initially, it'll be small, but targeted at specific cities. I think that the certification, the regulations, and the insurance aspects are manageable.
So does that include Bristol for not having a very good public transport infrastructure? But perhaps
it would also need to have the infrastructure that you could adapt to takeoff and landing areas, and you also need to have good connectivity. So urban air mobility doesn't really solve the whole problem because you're not going to go and land in your backyard. So there is a certain amount of connectivity needed.
Mr. Google and Mr. Amazon seem to think so, though. Simon, your point quickly.
Sure. Yes, I think it'll never work. No, I think urban air mobility has an enormous mountain to climb. Brett mentioned public perception. He's absolutely right. And when we start to add on to the public perception issues around rotorcraft, we add to that the green agenda and the thought of people watching others flying over their heads using vast amounts of energy whilst they have to queue for the bus. You can see that will cause some ill feeling. I suspect in the first instance that we will see urban air mobility in the context of niche application, very much like tilt rotor perhaps is perceived at present. I think we will see unmanned air systems doing a job of work. We can already see today the need for logistics, lift and shift tasks. And I think in the first instance, we will see unmanned air systems operating in the rural rather than the built-up environment. And I think they will be going there because that is a great operational environment to really cut your teeth and prove the efficacy and reliability and maintainability of the systems to then support your arguments to the airworthiness authorities to be able to fly over built-up areas. So will UAM happen? Yes, perhaps not in the some of the volumes that we see reported in the popular press, or indeed in more detailed analysis. I think it will be a niche application in the first instance, and then it will be down to society's appetite to tolerate all such activities against the growing green agenda.
Okay, thank you. Bianca?
Yes, no, I mean, I sort of have to second the previous two, really. Infrastructure, it's definitely going to be city dependent. And also, I think energy costs is going to be a big factor in bringing down, you know, how common these vehicles are. Because I mean, at the minute, batteries are still much more expensive than fueling an aircraft. So even if batteries cost the same amount as what fuel does, it's still more expensive to run. So part of it is waiting for battery and energy to go down in price enough that it becomes economical. And I think until then, hybrid solutions are probably going to be a lot more popular. Yeah, and I think also hybrid solutions, it means you can keep your battery cycle life longer, because otherwise you're thinking these batteries are going to get discharged very fast, very quickly. They're going to be sort of challenged within the limits of their application, because you have to remember that a lot of these battery technologies are being designed primarily for the automotive industry or for light aircraft, which can take much slower discharge rates. When you look at the spec sheets for different batteries and what they can perform at, it's the numbers that they quote are always for low discharge rates, like what you have in a plane or a car. When you take it into the rotorcraft industry, where especially when you're taking off or landing, your power is sometimes about double what you have when you're cruising, and that's going to be very difficult to achieve, I think. So yeah, that would be my answer.
Exciting. Dave, and then Jamal.
Yeah, I just second what everyone else has said. I think it'll be a slow start, but I really do think it will happen. I think it's a really exciting prospect, but I think it's going to be baby steps rather than the pace that the popular press and some of the people would say. But yeah, I think it will definitely be there, certainly within 20 years.
Thank you. And Jamal?
Yes, I think so as well. But so the air taxi concept, urban air mobility concept within the city, we see on one side, for example, cities such as Dubai already announcing the kind of their concept. This has been done kind of a couple of years ago, and then they endorsing that. But whether we're going to see it soon or not, that's a question mark there. Inside the city is still a difficult one, but I think we would see the urban air mobility concept tested first between cities in rural areas first for kind of transportations. Once there is enough confidence that these vehicles work well and operate well, I think then we should see them inside cities.
Okay, thank you very much. I'm afraid that's just about all of our time there. First of all, from myself and also on behalf of the Society, I'd like to thank the panelists for such an engaging discussion. It's really been a fascinating hour and a half, and we've covered new technologies, green technologies, urban air mobility, automation, lots of exciting careers. We also talked about regulation and certification. I'm sure we could have gone on if we'd been in sort of real life and perhaps have a couple of pints of beer to help us as well. This discussion could have continued, but thank you very much. Can I thank everybody who's tuned in from around the world and for sending in some fantastic questions. Apologies if I've not been able to ask all of them. I'd like to thank the Rotorcraft Specialist Group for putting on this event, and Kira as well from the Society for helping to make this fantastic. It's really been a really great event. Can I remind you all that the video of the webinar will be emailed out in about 3 days' time, and at the close of the event, a survey is going to pop up on everyone's screen, and the Society asks you to take a few minutes to complete this in order so we can refine the way that such events are run. You know, it's one of the things that has come out of the whole COVID situation is there's more and more of these remote events where far more people are able to get involved than we would do, and we hope to run such things in the future. So from the Royal Aeronautical Society and myself, I hope you found this a really engaging and enthralling event, and I hope that you'll join us all again. And with that, I'll ask you to enjoy the rest of the evening, or it may be late at night for some of you, and I hope to talk to you again sometime in the future. Thank you very much.